What is this? I have 3 circuits here. It's composed of 3 circuits. It's not a robot, but a transformer power supply. 12 volts, 9 volts at the top, and then the middle of 5 volts. So the 12 volts has an blinking LED. They call it a Saki oscillator. And in the middle, that is my 5 volt supply, a regular LED chaser. And on the top is a flip-flop mounted on 9 volts power supply. Let us see the circuit. So this is the power supply 220 to 12 volts. That is 220 to 12 volts. This one. We have the layout here. And then we have a bridge rectifier. Diode 1N4007. And there is an LED connected, that is the blue LED. And then we have the filter capacitor here, and then the regulator 7812, and then we got a regulated power supply 12 volts from unregulated to regulated 12 volts. And the output of the 12 volts is my Saki oscillator. See, the collector of the transistor is connected to the negative ground. That is an Saki oscillator with capacitor, resistor, and this is connected to the output. That's why you see that blinking LED, white. That is an Saki oscillator with my 12 volts power supply transformer enclosed in my old speaker case. And that's my regulator 7812. Here's the regulator, 12 volts, voltage regulator. That is the Saki oscillator. As you can see, that's an Saki oscillator. The famous Saki. What is that oscillator? So this is the layout. What is that? Let us see the circuit of the 9 volts. That one with 555 flip-flop. Let us see the circuit. What is that noise? So this is the 12 volts converter, 12 volts to 9 volts with flip-flop. That is the 555 timer. That is the voltage regulator 7809. And this is the schematic diagram. See, in the input side of the regulator, I use 2 capacitors. On the output, use 2 capacitors. And then to the output, the 555 timer, and I connected a 104 capacitor for voltage control stabilizing. And the LED is a flip-flop. These 2 LED. That's 555 timer in astable mode. As you see, that 2 LED red is a flip-flop. connected to the 9-volt supply. What is that? This is a binding post, also with binding post, and it is connected to the 12 volts power supply, converting it to the 9 volts with flip-flop. So let us see another circuit, a 5 volts supply. So this one is a converter, 12 volts to 5 volts. This is according to the data sheet of this IC regulator AN7805. You have to connect the input capacitor 104 at the input side of the regulator, and then the ground, and then the output is 100 microfarad 16 volts, and with this feedback diode IN4007 or 400 to suppress the backward voltage or the peak reverse voltage upon shutting down the voltage load. Also, this 100 microfarad output capacitor is used to stabilize the circuit. Also this one. So this is the layout, diagram, pin out, and that is in the middle with my LED connected to the 5 volts, converting the 12 volts to 5 volts. Converting this 12 volts to 5 volts, that blinking LED, that is the regular LED flasher, just a flasher. Unlike here, this is a Saki oscillator. On the top is a flip-flop 555 timer. Okay, we have 3 circuits in one. Let's check the voltage. First is the 12 volts. This one is 12 volts. We have 12.02 volts, 03. And this one, 9 volts. We have 8.96. It's dancing. The 5 volts in the middle is this one, 4.93. It seems in the middle 9 volts is dancing. .96, 12. So that's my laboratory bench power supply. A 12 volts, a 9 volts, and a 5 volts. With the circuit here. Kill the light. That is my power supply transformer type with 3 circuits in one. 12 volts, 9 volts, and 5 volts. Okay. Thank you. Bye bye.